So a few ideas. This is some content that has been used multiple times by the Odyssey Phenotype Development Evaluation Work Group. I encourage you all to join that work group because we all work together, build good quality phenotypes. But what is a phenotype? A phenotype is a specification of an observable, potentially changing state of an organism. This is something that was built, developed by the Odyssey collaborators and is published in several literature. There is the idea of a cohort definition. Now that you have the idea of what the phenotype is, you can then operationalize that by building a specification, the specification of how to identify the cohort. This is usually manifested as a lot of SQL code. That SQL code is rendered by the Odyssey tool Atlas. What is a cohort? A cohort is a result of applying the SQL code or the cohort definition logic on your data source, which is in the common data model format. So the cohort is a set of persons who satisfy one or more inclusion criteria for a duration of time. So we have the idea of a phenotype, we have the idea of cohort definitions. One phenotype may be represented by one or more cohort definitions. Each cohort definition materializes into a cohort, and a cohort may be a set of 0 or more persons. Now, an important thing to remember is in Odyssey, a code set is not a cohort. What we are really looking for is a logic of how these codes are related to each other in temporal sequences. And that's what is manifested in the code definition logic. We have developed a process of phenotype development evaluation. The phenotype development evaluation framework has a set of inputs, which is on the left side, and a set of expected outputs, which is on the right side. We've used this framework as part of the Odyssey Phenotype February and has been used in multiple other studies. The input is a clinical description. Clinical description allows us to develop a shared understanding of what the target phenotype is. We also take as input work that has been done by others in published literatures, prior knowledge from literature sources. Is there a validated definition that has been used in certain other studies? The expected output is code definitions. And code definitions, again, can be one or more for one target clinical idea or phenotype. And then we also come with an evaluation report. The evaluation report basically tells us how good is this code definition logic when applied on a data source. What are its operating characteristics? Are there any sources of errors? And this whole framework is done in the middle by using a set of tools. For today, we are focusing on the development part of it. We are not going to be talking about evaluation. Evaluation is part of the next week's work. Here, we're going to talk about the components that are part of these big circles here. On the left-hand side, we're going to talk about the required inputs, clinical descriptions, and prior knowledge. We are going to use the Atlas tool to build concept sets and cohort definition. And on the right side, we're going to output certain cohort definitions. That's the scope of today's conversation for the outcome phenotype definition. Very quickly about what this is. Again, there's an idea of phenotype development. There is an idea of phenotype evaluation. Phenotype development, it is the modeling the clinical idea, the target, using computer code that has medical vocabulary, temporal rules, with an intent to apply on a data source to generate a cohort. That's the development component. Then the evaluation is given a conceptual understanding of the target clinical idea, right? Using structured, qualitative, and quantitative approaches to estimate measurement errors present in the cohort. That's the evaluation. Evaluation is again next week. This week is all about development. Evaluation focuses on measurement errors. We are not going to be talking about measurement errors, but there are three main measurement errors that Odyssey has focused its efforts on. They are sensitivity errors, specificity errors, and index date misclassification errors. Again, that's part of next week's conversation. So I'm going to be focusing on the outcome phenotypes. Christian has already finished his task. So the next 30 minutes, you're going to be listening to me talking about outcome phenotypes. This study, as you heard, has two major outcomes, and that could be joined into one outcome as a composite outcome. They are the aortic dissection and aortic aneurysm. In our framework, we start by developing a shared understanding. What is this target clinical idea? What is this phenotype? We start by looking at an authoritative source. Recently, we started using the NIH published document called StatPulse. The reason why we like this is because this is a good quality document that's in the public domain. It is open source, it's open science, so it's available to everybody. You're also welcome to use other proprietary sources that are behind paywalls, but that's those are also good quality authoritative source. But this one is something that we have begun to use more commonly because it is a very liberal license. So aortic dissection, when I went to this link, I searched for it, and it has a long page, and just a brief highlights from that text. It is an acute condition. It is rare, and it is catastrophic. That's the initial description of it. What is it? It is the aorta is the big blood vessel that carries the blood from the heart to the rest of the body. It's mostly in our chest and goes all the way to the abdomen. It has many layers. It's layers of muscles. If the intimal layer is disrupted and the blood starts gushing into it, it's called aortic dissection. And that force of the blood keeps on pushing through the muscle wall, separating it out. And that's very dangerous. It has a very high mortality, and the majority of people appear to die even before they come to the emergency department. Now, very rarely, if for some reason it stops and it can heal, and those people may have something called a chronic aortic dissection, where it would last for more than 2 weeks. So they have a slightly better prognosis, but overall, acute aortic dissection is very dangerous, high mortality, causes abrupt in onset, and causes severe tearing chest pain. So that's the general insight we get by looking at that document. There's also the section called etiology. The etiology basically tells us that there is non-traumatic causes and there is traumatic causes. Traumatic is because you're in a road traffic accident, you're in a car and have met with an accident, and you could have an aortic dissection. But there's also the non-traumatic component, and non-traumatic component is because of most commonly because of an abrupt, severe increase in blood pressure. Maybe because you're enjoying cocaine or ecstasy or energy drinks, and that might be a cause. It could also be in individuals who are predisposed because of genetic conditions such as Marfan syndrome, or they may have a weak wall which had previously had a pre-existing aortic aneurysm. An insult, a weak aortic wall may be predisposed to have aortic dissection. So this is what we learn by reading an authoritative source. Now, in RSC, for the Phenotype work group, has recommended that in order to facilitate the shared understanding, let's translate what we've learned by looking at an authoritative source into a somewhat structured clinical description. Now, we're not rewriting a medical text. It does not have to be extremely long, but we ask for certain key components that we encourage you all to write about. So those components or sections are overview, presentation, diagnostic evaluation, therapy plan, prognosis, disqualifies, and strengthens. Now, this is available at the Odyssey Phenotype Library repository, and the URL is on the top. There are several guidance documents here that was written by the Phenotype Development Evaluation Workgroup. Please review those, and if you have any questions, we're available to answer them. So I took the content that I reviewed from StatPulse and created a very brief aortic dissection clinical description. It has the recommended sections, and it is pretty brief. It took me about 15 minutes to do this whole segment. So, overview: a tear in the intimal layer of the aorta, generally progressive due to entry of blood, causing catastrophic, life-threatening state with very high mortality. That's my overview. That's a high-level understanding of aortic dissection. It is presentation, it's acute, it's emergent, it's associated with tearing chest pain. Diagnostic evaluation, imaging studies, it's a clinical diagnosis. The therapy plan could be surgical or intensive care. Now, the prognosis, high mortality, very few people survive it. And in some people, it may reoccur, maybe. There is the idea of strengtheners and disqualifiers that we've introduced. Basically, if a person with the diagnosis also has a surgery for the aorta, that probably indicates that they truly had aortic dissection. The use of intensive care at the same time as a diagnosis of aortic dissection would suggest that they truly had this phenotype. Disqualifiers, if they have very frequent reoccurrences, like they have an aortic dissection today and an aortic dissection tomorrow, and the day after tomorrow, it's probably a continuation of the old episode, or maybe it's that particular event is not a true aortic dissection, but just a follow-up of a previous visit or a suspected aortic dissection. So that's the structure that I transcribed my readings. Similar work for aortic aneurysm. Remember, this study has two outcomes. There is aortic dissection and aortic aneurysm. A similar transcription of readings into aortic aneurysm. Aortic aneurysm is any permanent dilatation of the aorta at any location. So we're talking about abdominal, thoracic, aortic arch, thoracoabdominal. And this specification is important because if you start a study and you don't agree that the location is the entire aorta all the way to the abdomen, maybe some investigators may think it's just the thoracic region and others may think it's abdomen. And so that's important. So this pre-specification is important. It's also important for clarification. Sometimes some people have dilatation of the aorta, but that does not amount to aortic aneurysm. And that's pre-specification that aortic dilatation is different from aortic aneurysm is important. Now, presentation, aortic aneurysm could be asymptomatic, could be chronic, and it might be just something that is incidentally observed in a person. You could genuinely ask the question, are incidental asymptomatic aortic aneurysm part of the outcome definition? And I think for this particular study, those are included. And so a pre-specification of what type of aortic aneurysm, is it like an acute presentation of aortic aneurysm, or could an asymptomatic presentation be included, is something that we can capture in the clinical description. Why is this important? This is now building up to your cohort definition because it is justifying your design choices in your cohort definition. If there is a concept ID that says chronic aortic aneurysm, would you include that? The answer to that question is guided by the clinical description. The diagnostic evaluation, therapy plan, prognosis, strengtheners, and disqualify, similar to aortic dissection. So remember, in our framework, we have a set of inputs. Clinical description is one of them. The second important input is literature review. Before we even touch Atlas, we ask that you complete clinical description and a literature search. There are several key literatures that have actually developed and evaluated the phenotype of aortic dissection and aortic aneurysm and used in their studies. This is one of them by Chang Lee and others. They said they defined their outcome, which for their study titled Risk of Aortic Dissection and Aortic Aneurysm in Patients Taking Oral Fluoroquinolones. They said they measured the first occurrence of aortic aneurysm or dissection requiring hospitalization during the follow-up period. They showed their codes for aortic aneurysm and aortic dissection. They also said they wanted the use of advanced imaging studies such as thoracic or abdominal CT, transesophageal or transthoracic echocardiography, MRI, and angiography. And then they said, when we use the combination of the two, our positive predictive value was 92%. So that's one literature that will definitely guide us as we build our phenotype cohort definitions. The next study by Pasternak and others also said, well, we use first diagnosis of aortic aneurysm or dissection. We include the entire aorta, thoracic, and thoracoabdominal aneurysms. We require primary diagnosis with admission. So they're hospitalized persons with a primary diagnosis. This is the first clinical encounter. And we included the entire spectrum, likely severe and symptomatic. No, they said they justified the use of inpatient because that represented severe and symptomatic cases. So let's take a note of their choices. Now, the next one was by Dong and others. They said it was the first hospital admission in any diagnosis position, and we excluded certain types of patients. All right, let's take note of that. Gopalakrishnan and others said hospitalization with a primary discharge diagnosis of aortic aneurysm or aortic dissection. So if you notice, we looked at 4, there are several more. Each one of them has slight variations in their definition, and some of them provided the operating characteristics and others did not. But these are the this is what is revealed from literature search. So if we synthesize those, you can see that there is some variation. Almost all of them required hospitalization. 3 out of the 4 required them to be the first occurrence. Only 1 you required diagnostic images, and 2 out of the 4 required primary diagnosis. So if you look at the commonality, and if I were to simplify, I would say, since all the studies required hospitalization, maybe we should also require hospitalization. And that kind of makes sense because this is a life-threatening condition. And if it's a life-threatening condition, hospitalization makes sense. Maybe even ER visits make sense. So let's say hospitalization or ER visits. Now, the idea of first occurrence. Let's table that for now, and I'm going to go to the next one. The use of diagnostic images. Only 1 of the 3 has used diagnostic images. So maybe we should use diagnostic images, maybe not. It's up in the air. Majority have not used diagnostic images. Primary diagnosis. This is a flip of the coin. 2 out of 4 have not used it, and 2 of the 4 have used it. So maybe we should think about it. Why did that happen? Now, let's talk about first occurrence. Now, first occurrence is kind of unique. We read in our clinical description that these may reoccur. Our task right now is to phenotype this. If this is a truly reoccurrence event, then we should allow for the phenotype definition to reoccur, for the person to have this event again. Now, Odyssey analytical tools are able to handle reoccurrence. We can say in the analytic configuration that we're going to restrict to the first occurrence. In other words, if persons had the event before the start of the exposure, we can remove them from the analysis. And that can be done as an analytic specification. So we don't have to worry about first occurrence in the phenotyping stage and handle that in the analysis. So you just have to remember that certain things can be handled during analysis and certain things can be handled in phenotyping. And the first occurrence idea does not need to be handled in the phenotyping. We can model reoccurrence events and then handle it in analysis. So this simplifies the whole combination into 2 flavors for me. Flavor number 1 is hospital plus primary diagnosis. And flavor number 2 is hospital plus any diagnosis. The diagnostic images could add flavors to this, but let's simplify because only one publication uses diagnostic images. Let's simplify and say flavor 1 and flavor 2, 2 flavors, hospitalization with primary diagnosis, hospitalization with any diagnosis. So the next step, we have completed the components as described here. We have the clinical description, we have prior knowledge. Now we're going to go into the tool. Before going into the tool, and there's another recommended practice. This is to conceptually think of how you're going to build your definition logic. On the left-hand side is a screenshot of the skeleton of the cohort code definition logic as presented by Atlas. There's 4 components to it. Component number 1 is on the top, which is called cohort entry events. What events lets you enter the cohort? Remember, in Odyssey, we think in terms of events occurring for persons. Events are timestamped observations of a healthcare, either a diagnosis, condition domain, a procedure, an intervention, a measurement, or an observation for a person. So what events lets you enter? The second segment in Atlas is the inclusion criteria, which is what inclusion criteria are required for these events. If you're satisfied, what rules should continue to be satisfied for the events to stay in, is I think another way of describing it. And the code exit is for each event. How long do you satisfy This is mixed up. Hold that thought. Okay. So there are 4 segments: cohort entry, inclusion criteria, cohort exit, and cohort error. Cohort entry events is could be for aortic dissection and aortic aneurysm, could be any diagnosis or procedure that is used to treat aortic aneurysm or dissection. If a person has a diagnosis of aortic aneurysm or aortic dissection, those events could allow the person to enter the cohort. If somebody had a procedure that it is an emergent procedure for the treatment of aortic dissection or aortic aneurysm, that probably allows the person to enter the cohort entry event. Now, inclusion criteria, what additional criteria should the person for the event continue to satisfy to stay in? Now, one example is the requirement of inpatient stay. We would like those events, those diagnoses, those procedures to happen in an inpatient stay. Another requirement could be those diagnoses should be in a primary position. So only events that satisfy the inpatient stay and or for flavor 2, primary diagnosis will continue to stay as an inclusion role. The cohort exit could be the end of the inpatient stay, as an example, or it could be the last date of that diagnosis. And cohort errors is a little bit more complicated topic. It is not relevant for this particular phenotype because this is an outcome phenotype. It's used in an outcome for an outcome outcome of a study. So for an outcome, what is most important is the cohort start date. Now we have a challenge in Odyssey of how to properly define an exit criteria for a phenotype. So I'm going to skip that component right now, and there's an unsolved problem in Odyssey. So to simplify, I would describe the logic as all events of aortic aneurysm or dissection with a 365 days washout that occurred in an inpatient setting with persons persisting till end of the event. Now, I'm saying all events of aortic aneurysm or dissection because a person may have the diagnosis or a person may have aortic aneurysm more than once. We are requiring for a 365 days washout, and this is an assumption that I'm making. When we reviewed literature on this topic, it said that most of the time there's about 6 months to 9 months of follow-up care for a person who's managed for an aortic aneurysm or dissection. If that is true, then maybe all the diagnosis that happened in that 6 months to 9 months period is not a new event, but is actually a continuation or the management of a previous event. So let's apply a washout rule, and the 365 days just seemed right, and I used the 365 days, and I said if there are 2 events that happen within 365 days of each other, we'll apply the washout rule. And then there are 2 flavors. The flavor number 1 is with inpatient stay with primary diagnosis of aortic aneurysm or dissection. Flavor number 2 is with inpatient stay with aortic aneurysm or dissection. There is no primary diagnosis requirement. So we're going to try to model this logic in Atlas. So far, do we have any questions before I go into Atlas? Okay, don't see any hands. All right, so there are, so the first, I'm going to take a 2-step process here. The first step is going to be to build a concept set. The second step is going to build a cohort definition. There are 2 ideas that we are trying to model. There is aortic dissection and aortic aneurysm. So I'm going to use the Atlas PB tool, which ChatGPT recommended, to build the concept set expression for aortic dissection. Aorta dissection. Makes sense? All right. So there are 2 icons here. This is a simple text search. This is PB 2.0. If anybody does not know what PB 2.0 is, do a Google search. There's a nice several nice articles on PB 2.0. So I'm going to press the recommend icon here, which has the shopping cart icon, and it says loading recommended concept in new concept set. It goes to the recommended tab, but before I look at the recommend, I'm going to look here, and I search for aorta dissection, and I get dissection of aorta. Cool. Now, under the dissection of aorta in the included concepts, there are 14 included concepts, each with its own record counts. And most of these dissection of aorta, non-traumatic dissection of aorta, makes sense. And this is handled completely by the Odyssey vocabulary, the SNOMED vocabulary. And when I look at it and scan through it, they make sense too. Now, there is a tab here called recommended. The recommended has 23 recommended concepts that PB 2.0 has provided to us. It is basing it on 3 types of reasons. One is lexical, which is basically string similarity. And then there is ontology parent, which is using the vocabulary hierarchy to provide recommendations. And then there is this new one, which is really, really cool, which is patient context. Patient context is based on a calculation, which is based on cosine similarity. So given a concept, it's defined here. It's a pairwise cosine similarity based on vectors of concept co-occurring with a given concept. So persons who have this given concept also have these concepts. We have 14 concepts. When I look at lexical bias standard, it is recommending coarctation of aorta. Now, I know what coarctation of aorta means. It is not aortic dissection. It is a narrowing of the aorta. So I'm not interested in that. I look at the ontology parent. And as I glance through this, none of this relates directly to dissection. Maybe this dissection of the aortic arch. Okay, gonna check that, keep that in.
Ué, mas nós vamos sair?
Vamos 1h30.
Ah, tá.
Vamos comer uma pizza aqui lá.
Oi, como?
Now let's look at patient context. In patient context, I see some more dissections, but this is of the renal artery and iliac artery. So I don't think that's an issue that is of importance to me because it's lower down. It's not part of the aorta anymore. It's after the bifurcation of the aorta. I see several aortic aneurysm. So from a patient context perspective, it makes sense. There are people who have aortic dissection. Also, if you have aortic aneurysm, it's a comorbidity probably. So that makes sense. Remember, we are not interested in aortic aneurysm in this concept set build process. We're interested in aortic dissection. So I think based on this process, I feel pretty comfortable, and I'm going to call this as SOS demo aortic dissection. And that concludes the build of my aortic dissection concept set. I'll press the optimize button, and it says the concept set is fully optimal. So I'm good here. I'm going to now go and build the concept set.
Gowtham,
Yes.
Evan's got his hand up, so maybe we just take a quick second.
Yeah, sorry, Gowtham, I'll just ask quick. There were some concept sets there in the recommender that that stated rupture of aortic aneurysm. And I wonder if conceptually that actually is just a dissection. I mean, I think I've used those as synonyms that could have been wrong. But that might be another consideration. And we don't have to do it now. We can kind of take a look at it afterwards. But it looked like there were some there that were rupture of aortic aneurysms at different locations.
Yep, absolutely. So there is, so Evan, you brought up a very important point here. When we are developing cohort definitions and we are making choices, we do not know if those choices make any impact at all. And whether that will increase the person counts in our cohort, whether it will improve, reduce any errors that may exist, sensitivity errors, specificity errors, we don't know. So if the concept the name of the concept name is pretty clear and it semantically, lexically makes sense, you could include it. But if it's controversial and you're not sure, we could do two flavors of the cohort definition, evaluate them, and see if it even matters. Does it change the cohort count? Is the profile of persons different with that extra code versus not? And that whole discussion goes into the evaluation framework. But right now, you could say maybe that comes under dissection. It could be aneurysm. There's an opinion.
And if I could add to that, Gowtham, Jack had mentioned in the chat, there's a desire here for this study to consider aortic aneurysm and aortic dissection as separate clinical ideas, as well as created a composite. But the point that Evan's raising may be something that when Evan does the evaluation next week, we can actually look into, which is, can we cleanly distinguish the aortic aneurysms from the dissections, given that the vast majority of the aneurysms are in fact ruptures? If there is ambiguity of whether a rupture is an aneurysm or a dissection, then that may prompt us to consider that the composite, clearly it makes sense that whether you call it an aneurysm or a dissection, it's going to count, but it may raise questions about whether or not we can cleanly delineate these two subtypes within the composite.
So I see we have 7 minutes of 7 officially in the clock, so I'm going to try to speed up here. So it's a similar idea. I searched for aorta aneurysm, got this as a recommended concept set expression by Phoebe 2.0. I look at recommended here. I'm going to filter by aneurysm. And I see several candidates here. I see aortic aneurysm repair. That belongs to the procedure domain. That makes sense to me. Aneurysm of the heart, no. Aortic aneurysm screening, no. Ruptured aneurysm of the artery. Some artery, no, I don't know if it's aorta. I'm going to skip it. Endovascular repair of the abdominal aortic aneurysm, yes. Endovascular repair of the infrarenal abdominal aortic aneurysm, yes. So I'm going to make choices based on just semantic interpretation and add them to my concept set. Keep on building. Every time I add a concept set, the recommender recalculates and provides me new recommendations. And I can go through this entire list, sort it by the descendant record count that's available through the concept prevalence study of the Odyssey network, and select concepts to my concept set and keep on building my concept set expression. I then ultimately save it as and this is how you build a concept set expression. Now, always try to optimize, and optimization usually reduces the number of concepts. Now, since we have previously done this, this is not the final concept set expression. The final concept set expression that was iterated on by others in this effort is shown here. There is an SOS aortic dissection and SOS aortic aneurysm that was chosen by others who worked on it before me. So the next step, we're going to use these concept sets: aortic dissection, aortic aneurysm, import them into cohort definitions. The key thing here, though, is if you look at aortic aneurysm concept set expression that was built out using the PB recommender system, and you look at the included concepts, there are 137 concepts here. They belong to several domains. There is codes from procedure domain, condition domain, and observation domain. This has important implications when we actually go and build the cohort definition. So I'm going to just remember this, that the aortic aneurysm has codes from multiple domains, while the aortic dissection does not. The aortic dissection has 14 codes, and it belongs to only one domain. Now, in the presentation, we talked about a certain logic. So we are implementing this logic right now. I'm going to go to cohort definition, build a new cohort. First step, I'm going to import those concept sets from the concept set repository of Atlas. And this is this takes a few seconds, but it'll be that. We're going to show you. So I'm going to search for that SOS aortic aneurysm and there's one repository second. I'm going to import aortic dissection. So I have my two major concept sets. First, I'm going to define the cohort entry event criteria. There are two concept sets. I'm going to start with aortic dissection. Aortic dissection concept set belongs to only one domain. So there it is. That's it. That's done. Now I'm going to do the other aortic aneurysm. Aortic aneurysm belongs to three domains. So there's domain number one, aortic aneurysm. Domain number two belongs to the procedure domain, aortic dissection aneurysm. Observation domain, aortic aneurysm. So I now have persons who satisfy any of the following criteria of the condition. This should be this condition, procedure, observation of the aortic aneurysm, or condition of the aortic dissection will be included. Remember, we are modeling an event cohort, so limit initial events to all events. That will give me every time, every unique date that the person has these codes, they enter into the cohort. Now, in our logic, we decided to limit persons to have a 365 days washout. So I'm going to implement the logic of the 365-day washout here. And to do that, we will pretty much replicate this, but we will have temporal rules associated with it. So the first one is the aortic dissection. They should not have aortic dissection. They should not have exactly zero. Of what? Aortic dissection. When? In the 365 days before. That 365 days starts here and goes here. 365 days before to 1 day before. So this prevents, this is the rule for the washout for aortic dissection. But now we have to do the same thing for aortic aneurysm. So condition occurrence, exactly 0. Aortic aneurysm, 365 days before to 1 day before. There's multiple domains. So there is observation domain, exactly 0. Aortic aneurysm, 365 days before to 1 day before. Procedure domain, aortic aneurysm, exactly 0. 365 days before, 1 day before. So this implements the washout period. Let's call this SOS tutorial aortic dissection or aneurysm. Now, this still doesn't satisfy the requirements of our core definition logic. Our core definition logic says you have to satisfy all these criteria. So we need inpatient stay. So how do we make inpatient stay? The inpatient stay, an inpatient or ER stay. So we're going to have an inclusion rule and say should be inpatient stay. Now, the way we can do this is to have visit occurrence. We import a concept set. And I know there is a concept set that says inpatient. Here is the inpatient concept set expression, inpatient visit, ER room visit, ER room, and inpatient visit. Resolves to 33 codes, 33 concepts in the visit domain. Then, okay. Should be inpatient stay, and here I will say it has to be all days before to 0 days before additional constraints event ends, 0 days before to all days, 0 days after to all days after. So let me explain what this is. So remember, these are events. Events are dates. We want that date to overlap with an inpatient stay. That way it makes that event an inpatient event. To overlap an inpatient stay will have a visit start date and a visit end date. We want so here at the bottom here it says index date refers to the event of the cohort entry criteria. This is the event, inpatient event. We want the inpatient event, visit start date and visit end date to overlap the index date, which is the entry event. To overlap, the start date of this should be before the index start date, and the end date of the visit end date should be after the index start date after this. And that logic basically makes sure that this is an inpatient, this is occurring in an inpatient stay. Now, that still doesn't complete our core definition logic. This rule satisfies the inpatient rule, but we want the inpatient rule to also be a primary diagnosis. So how do we make that a primary diagnosis? So here we have to say it's a condition occurrence, aortic aneurysm, 0 days before, 0 days after. So, and add an additional attribute, condition status, and we press the add button. So in most ETL conventions, condition status concept ID. Condition status concept ID is a separate field in the condition occurrence table. Represents whether the diagnosis is primary or not. The usage of primary versus secondary is mostly a US claims data construct that may not be present in many other data sources that is not does not have the conventions of a US claims-based data. So this particular rule, when implemented, may not generalize itself to data sources that do not have this concept of the primary diagnosis. So given that caveat, I'm going to search for primary here. And there are these codes: primary admission diagnosis, primary diagnosis, primary discharge diagnosis, maybe primary referral diagnosis too. And I'm going to add these here. That gives me the condition occurrence of aortic aneurysm, which with the status of primary diagnosis as represented by condition status code. Temporally, it's on the same day as the entry event criteria. Now, that's just one. You got to have another condition, and that's the aortic dissection. Again, 0 days, 0 days. And we need just any of these. And I'm going to add the condition status here. Add again, search for primary. And now we have primary diagnosis. Now, if you remember here, aortic aneurysm can come from multiple domains: procedure, observation. I'm not putting procedure or observation here. There's a reason for that, because there is no primary position for procedure or observation. So because there is no primary position, I can't use that rule in this particular context. So if we want primary position, that's my definition when I say primary. And this is my flavor 1. Now, I need 2 flavors, one with the primary position, another without the primary position. So I'm just going to copy this and say flavor 2. And I'm going to remove the primary here because I want one without primary. I'm just going to remove this rule. And there I have my 2 cohort definitions built on. 7 minutes over stipulated time.